Hey guys, this is the first part of our new topic, software development lifecycle. Let's see what we got for today. So I'm gonna introduce the life cycle of the software development. So it is a methodology for developing software, but this methodology is based on object-oriented, which is our desired paradigm. Okay, so let's start from the very beginning. Every contract has two parties. So what does it mean? Since we want to practice whatever is being happening in the real world, right? I am gonna simulate exactly the same thing in this class. So in the real world, every contract has two parties, right? So one is the client that is requesting a service. The other one is contractor that provide the service. Okay. So in this course and in this class, I will be the client and you will be the contractor. Okay, so I request something and you will provide that service. And in some cases, of course, you will play both of them. All right, so let's start. So, what is the starting point? The starting point is the client will request a service. Yeah, so they want to solve a specific problem. Then what we are gonna do, uh, they provide this problem in a document that is called problem statement. Okay, so they define the the problem that should be solved in this document that is called problem statement. Okay, so there are, many questions that we should answer here. So the first question probably is, what is the ingredients of this document, and who will write it, and who will read it, and who will use it? So all of these questions we should answer in the next slide. Okay, so problem statement try to describe clearly the problem. Okay, but most of the time this is not the case. Whatever your client will write, most of the time, most is 98% of the time, it is not so clear because they still don't know what they want, right? So, but in theory, problem statement tries to describe everything very, very clear. Okay, so if they can make it as clear as it possible, then that would be great. Even we have a code for this. A problem well stated is half solved. So if you clearly can, talk about a problem, so you actually solve it 50%. So 50% of the problem is solved if you can state it and speak about that very clearly. So this code actually was from this guy Charles Kettering, and he was from the General Motors. Anyway, but it's very good, code. A problem well stated is half solved. Okay, now let's see who, what's the ingredients of this problem statement document. This document has three major parts. First, the problem. So three parts, right? The first one is the problem. So you need to explain how the world looks like when this problem exists. Okay, you should, try your best to say, okay, the people are suffering from these problems, and this, there is something that, if this is the lack of the benefits that we need to solve. So try to describe it and try to point out the negative points of how the world looks like now. After that, when you finish with that part, then we will have a vision part. The vision part is saying that if we solve this problem, the world look like this, and start, stating some positive things that, yeah, so this gap that you explained here will be filled with this. All right. And the third part is called domain, which means who will get the benefit of this, who will affect this problem and the solution. So you specify the domain of the or audiences of this software, those who get the benefits. And of course, the order doesn't matter here, even though this is a very reasonable order. But in some cases, you might put these domain inside the problem as well. You mentioned that way. It is okay, right? Okay, so this is another point of view, you know. So in this case, you explain about the current state, which is the this part, and then you will talk about this part, which is if the problem is solved, the future looks like this, and then you will say, yeah, there is a gap between this state and this state, and this software is gonna fill this gap. This is another point, looking at, another angle for looking at the pro problem statement. Okay, now let's a little bit talk about in detail about the problem and the vision and the domain by an example. So our software is called Task Reminder. Now let's see how I state the problem. Now I have to read all of them for you. So nowadays, at least 40% of people are working remotely from home by using computer. Actually, this 40%, I'm not sure that it's accurate or not. This is just my guess. People are busier than before, and everyone need to do many tasks. So you see how I am trying to state the negative things that is currently this situation has, you see. So yeah, people are busier than before, and everyone need to do many tasks. Remembering all the tasks needs a task reminder software, and current OSs do not have a flexible built-in task reminder system. And if we go to for the free stuff, the open source one, are either inflexible or they are spyware. Yeah, all negative thing. Yeah, you see, we are describing how negative this current world is. And the commercial ones are not affordable. So yeah, this is the description how the world looks like right now. And now we go to the vision. Okay, we want to solve this problem. So we need a flexible task reminder software that it should, fill this gap. The users can be notified with a suitable message when a task is due. User can add, delete, edit, activate, and deactivate the task. The data will be, stored permanently. So in this case, we are a little bit talking about the software itself and the benefits that it will give us. And also, we are assuring uh, you know, the people that they don't need to install anything else. This is a self-contained software, and it can be run on all existing OSs such as Windows, Mac, and Linux. So here we gave a vision about what we are gonna do in the future by producing this software. And then we stated the domain, what people will affect. All people who work with computer can use this software. All right. Okay, now let's talk a little bit about the general characteristics of this problem statement document. So first of all, it is, written by the client. Most likely the client will write it, but in some very rare cases, they might ask, the contractor to do that, or maybe they make a new contract for someone who write it, but most likely it is written by the client. So the the literature that is being used in the problem statement is a plain, non-technical, in natural language I put here. So here in United States, of course, English. So plain English, non-technical. Okay. So it focuses on just one problem. Yeah. And it does not suggest any solution. So it is not saying that, yeah, we will be using this technology, that technology, we will be using in the back end, for example, we the Oracle or MySQL or whatever. So there is no specific solution for that. It's just description of the problem and the description of what would happen when the problem is solved. Okay, so also it is from the end user point of view, right? End user point of view, someone who is using it, right? It's not technical at all. It will be readable by specifically for by the business analyst of the contractors. But since it is a plain English, statement, uh, almost everybody, contractors, all of the contractors team can read it and understand it, and there won't be any problem. All right, and uh, we need to quantify as much as we can. Okay, so this quantification is important when you want to, explain about something instead of saying that, yeah, some people, yeah, some people is not a scientific thing. It's not a desirable thing. You should mention a number. Even it is, very, it's an approximation. It's okay. So it shouldn't be that much. If it is, of course, accurate is the best, but approximation is also desirable. Better than just using some, uh, you know, uh, unknown values. For example, some people, major people, or majority of the people, no, that's not a good idea. Anyway, so if you want to, make it clearer, or if you don't have any idea how you should start it, right? So there is a way that you can use that. So it is called 5 W's plus H. So in some articles you might see just 5 W's. In some articles you might see 5 W's and 2 H or 3 H. I don't know. So But I am just mentioning this here for your reference. So this way you can start writing. How? Yeah, with answering this question. So when you answer this question, what is the problem that should be solved? So why it is a problem, right? So when you are answering these questions, there are more. Where the problem is observed, who is impacted, and when does the problem happen, and how is the problem observed, something like that. So when you answer all of these questions and then play around with these answers, then you try to construct the skeleton that I gave you in the previous slide. So problem, vision, and the domain. All right. So you need then at the, ultimately prepare that skeleton. Okay. So this is a starting point if you don't have any idea what to say, what to write. So just try to answer these questions. Now let's talk about the main topic, software development lifecycle or SDLC. Okay, up to this point, we have the problem and we know that there is a problem that it should be solved by producing a software. Okay, so now the question is how can we start coding? So this process, the whole process of producing a software is divided into the some stages, right? So or phases, okay? And okay, so before going further, let me ask you this question. When we divide a problem into a smaller thing, what principle is this? Okay, yeah, I am sure that most of you answered correctly. Divide and conquer, right? So based on this principle, we need to divide the whole process of producing the software into some phases, okay? And this is the phases that we will, break all of the process into. So it is 7 phases. First phase is called planning, analysis, design, implementation, testing, delivery, and maintenance. So these are 7 well-known uh, phases for developing a software. Okay, and this sequence from the 1 to 2 to 7 is called software development lifecycle or SDLC. Okay, so this life cycle, you might are wondering that why we are using the life cycle. So this is actually a metaphor for the human life. So the human life is starts with conception, and then we have childhood, and then we have adulthood, and finally death. Okay, so if you want to prevent your software dying, then you would need to do some stuff, yeah, that we will mention during the semester. Otherwise, if you fail to do those things, yeah, your software is doomed to die. Okay. So let's see which one I'm gonna cover in this course. So these are the 7 I repeated here. Um, okay, and we will cover from 2 to 5. Okay, so from analysis to testing. So the planning actually is a very important part, but this is beyond the scope of this course. In the planning, we start planning for the resources, for the time we would need, for the money budget, right? How many people we need, how much time we need, and how much budget we would need for that. And then we will create a project plan and these kind of things. So I am just giving you some taste here, and hopefully you will see it in the software engineering course. All right. Okay, before going further, we would need to be familiar with a new term. So this new term is called artifact. So what is artifact? So when we start talking about each phase ultimately have an output. Okay, so what is this output? This output can be a textual document, it can be source code, it can be diagrams, it could be combination of this, and even it could be some video or audio and some other stuff. So every phase has its own output, and that output is called artifact of that phase. Okay, so we will be using this artifact, at least when I am talking about this SDLC, we will be using that, you know, a lot. Anyway, so now let's start with the analysis. Okay, so from now on, until we finish this analysis phase, uh, we change our hat. Now we are business analysts because we are going to do the analysis of the software. All right. Okay. So let's see what is analysis. What is the goal of analysis? So we said that we have the problem right now in the problem statement document. So the problem is clear for us, almost clear for us. Now, business analyst job is to, set some meeting with the client and try to understand what the problem is. So many meeting with the client and interviewing with the those people who are gonna use this software. So there are many interviews. Then business analyst transfer all of these his or her findings into what? A precise description of all of the tasks that this software is going to give us. So all of the services and benefits that our client is demanding. Okay, so the output, what would be the artifact of this phase? The artifact will be functional spec or functional specification. We will be using this functional spec for the abbreviation. So let's see what is functional spec and what is its gradients. So functional spec, as we said, is an official description of what? All of the requirement that is demanded by the client. And so who will write it? So definitely business analyst or BA. Who can read it? Who can use it? So the client can use it to make sure that we as the contractor understood what we should produce, and also it can be readable, it can be read by the designer, because designer is the next phase. So the output of the analysis phase will be the input for the design phase. So designer is someone that should be able to read it very clearly. Okay, now the question is, what is the ingredient of this functional spec? The ingredient of the functional spec, first of all, it describes the problem. All right. So you can either just repeat the problem statement that you got from the client, but this is not a good idea in real, project. So you need to clarify the problem statement, uh, and probably more details about the problem. But in the worst case, you can just copy and paste from the client, this way. And also it describes all of the required features, right? So here we just describe the problem, but here we are in detail now. We are, enumerating all of the features that are demanded by the client. And please note that in the functional spec, we just say what the software is supposed to do, not how. Yeah. So we are not giving a solution. We are just describing that, yeah, this, software is going to do this, to do this, to do this, but not how, right? All right. And also another ingredient of this functional spec is the use case. All of the use cases. And I will cover it shortly. So, and also it includes the mockups. So what is mockup here? Mockup is a screenshot uh, of the software that you are gonna produce. Okay, so you can create a superficial. Um, um, it's not a real code. You are not gonna write a code to produce this mockup. So you can use some other tools like this. That is a very nice tool. Um, Adobe XC. It's called Adobe XC, and you can download it here from here, and probably maybe you can download it from the university's website. I'm not sure about this, but you can check that. But in the worst case, you can download an evaluation version, and you can use during the semester. So yeah, for the more detail, I will provide everything in the term project. All right. So here is some examples of the mockup my previous semester students created, right? And this is another one. Yeah, you can create anything that you like. It's a very fantastic tools. So that's your job to install it and get familiar with that. Okay, now let's talk about the use case. What is use case? So we said that our software is going to give the client some benefits, right? Or some services, right? So we should be able to enumerate all of these benefits in somewhere. So, for example, yeah, my software is going to give you this benefit, this benefit, this benefit. So, a list of all of the benefits that your software is going to give the client. Okay, and use case is a description of one of them. So every one of those benefits or features is called a use case. So in use case, you are going to describe a step by step about only one benefit. So how the user and the system will interact with each other to produce or to give that benefits. Okay, I will take some examples to clarify that, but just remember that we are still in the analysis phase. Yeah, and also you should remind that the BA is going to write all of these stuff, the use cases. Okay, so let me take an example about the use case and to make it, very clear. So let's assume that we are going to write an enrollment system. So in enrollment system, one party will be the student, the other party will be the system or the software. So we all always have two parties that interact with each other. Okay. So here are some possible use cases. For example, login to system is a use case. Sign up is another use case, right? So you need to describe step by step what would happen between the user and the system when this login to system is going to be run, right? How about the sign up? If user does not have username and password and want to sign up, then what should this user do? You need to, describe every of these step by step. Or searching for a course is another use case. Enrolling in a class, adding a course, dropping a course, checking out, etc., etc., etc. So enrollment system has these possible use cases. So all of these are some benefits that your software is gonna give to the user. All right. So let me take one example about this login to the system, and let's see how it works. So there is two parties here: the user, or here probably a student, and the system which responds, or the software. Both of them are actors. Okay. So when I say what is the actors of this, use case, you would say, yeah, so one of them is students, or the other actor will be the system, right? In some cases, maybe the administrator is working with the system, then the actor will be administrator, right? Or operator, right? It's not the case that always we have the end user as the first actor. So anyway, so log into system. So user runs the software. How the uh, system will respond? The system shows the login page. Then what? Then user enters this username and password, and then click on the login button or press enter key. Uh, you could put this way, or you could separate this clicking thing in another one here, right? I just combine both of them in one step. And after this, what would be the response of the system? System will verify the username and password, and then shows the welcome page or home page, whatever, right? So that's it. So this is a use case, and very simply we described what would happen. And and then based on these steps, designer will design the software and implementer will implement the, write the code. All right. But it is very important that for every benefit or every feature or every requirement, all of these have the same meaning, of the software, we have a use case, a very well documented use case like this. Okay, so up to this point, we assume that everything is fine. We are living in an ideal world. But is this the case? No. Sometimes something goes wrong. So whatever I explain, we call it happy flow or happy scenario. Yeah, it's an ideal situation, but we will have an unhappy scenario if something goes wrong. Okay, so here is an example, the same example, log into the system. Yeah, so what if username and password and or password is incorrect? Yeah, and the login will fail. So in this case, what would the system do? All right. So that's why the business analyst should predict all of these stuff, and we call it variance. So all of these, failures should be predicted in advance by business analysts. All right. So all of these we call it unhappy scenarios or just call it variants or alternatives. So here is one example. So the variation of number one for the previous example would be in step four, username and or password are wrong. Then system shows a red message. Your username and or password is incorrect, please try again. And then system stay at the login page. Okay, so, okay, now let me show you a demo about I provided a use case form, a template for the use case. I'm gonna show you quickly what it is and how it works. So I have already uploaded it in the Canvas, files, term project, and templates. This is a simplified version of the use case form. So this is a doc, I mean Microsoft Word doc format. So you can download it, and for every use case, you can just copy and paste this table, right? Any, as many as your software is required. All right, so let me very quickly explain what is this. So the use case name, you create a unique name for your use case. All right, and also you will explain that what is the goal of this use case. Very, shortly describe that what is the goal of this use case. For example, this use case describes how a user log in into the system. All right. And then you will specify uh, the actors. So which actors are participating in this use case? For example, user and system, or a student and system, or in some cases, yeah, let's say operator and the system. So most likely one part, usually is the system, which is the software, I mean. And if you are gonna use any abbreviation or acronym or something like that, or there is a complex concept, you need to describe it here, right? So before going further, if someone is reading this, so it's a heads up for him or her that, yeah, this is gonna be using during this, this use case. Anyway, and here is the primary flow of the events. Primary flow, it means that happy flow that I just explained. So how this use case will be triggered? For example, user runs the application or user clicks on that button, right? So you need to describe how this use case will be activated or triggered. And then here you explain about the action, which is one party or one of those actors, and this is the system's response. So you need to explain what the user do and how the system will respond. Then what the user do, what the system. So all of the the tasks that user is gonna do for getting a benefit of this use case, it goes to here, and for the system's response goes to here. And if you need more, of course, you can add here. Yeah. So yeah. And here we have the alternate flow of events, or let's say unhappy flow, right? So how it will be triggered, you explain here. For example, the user clicks on cancel button, right? And then you will, exactly like this guy, will explain what is happening in the unhappy situation, or the variance situation. All of the things that user is doing here, and all of those things that the system will be responded. So this alternate flow, this guy can be many, many, variants, right? You can copy and paste and here and add it here. So let's say, for example, alternate number one, number two, and blah blah until the end of that. Anyway, so this is the form for one use case. Um, we will be talking about that in the future, when I will assign the term project. That's what I have for today. See you guys in the next lecture.